In this basic relationship between pixels, we'll be seeing about the neighborhood, adjacency, connectivity, paths, regions, and boundaries. So this example shows the points, coordinates, how it is located for any image. So the first point is considered as 0, 0. The next will be 0, 1, 2, 3, 4, etc. in the horizontal way. In the vertical direction, it will be considered as 1, 0, 2, 0, 3, 0 in this way. So any neighborhood will be denoted as the points surrounded by any pixel value in the four directions, in the vertical side, in the horizontal side. For example, for image, for a coordinate, for image block, in this image block, coordinate of f of 1, 1, the neighbors are 0, 1, which is x minus 1, y, and 1, 2, which is x, y plus 1. Same way, 1, 0, x, y minus 1, and next will be 2, 1, x plus 1, y. So these are all the coordinates of the neighborhood of pixels. So it will be having four horizontal and vertical neighbors. This set of pixels is called the four neighbors of P. That is the point of interest f of 1, 1 by denoted by n4 of P. Each pixel is unit distance from x of x, y. What is meant by neighborhood? A pixel P at coordinate have the four diagonal neighbors. Their coordinates are f of 2, 2. That is the right side diagonal way. It is called x plus 1, y plus 1. Same way f of 0, 0, which means x minus 1, y minus 1. 2, 0, which means that x plus 1, y minus 1. 0, 2 is x minus 1, y plus 1. So this set of pixels is called diagonal n neighbors of P, and they are denoted by nd of P. Diagonal neighbors plus 4 neighbors, totally we will have the 8 neighbors of P. They are denoted by n8 of P. So n8 of P means 8 neighborhood pixels, which is the combination of 4 neighborhood pixels plus 4 diagonal neighborhood pixels. Then comes the adjacency. Two pixels are adjacent if they are neighbors and their intensity level V satisfy some specific criteria. For example, in this block of image, we have the values only ones and zeros. So it has the combination of V. The total intensity levels are 1 alone. Binary image means it will have a 0 and 1 alone. For example, if it is having only 1, all the image will have only the value only 1 alone. For example, a grayscale image will have a value from 0 to 255. For example, V of 0, 2 means it will have the combination of only 0 and 2 alone. In binary images, two pixels are adjacent if they are neighbors and have some intensity value, only either 0 or 1. In grayscale image, it will contain more gray levels in the range 0 to 255. Here, P is the red color, which means that is the point of interest of a image block. In this, the point of interest P. Q will be anything in green color, which means that two pixels P and Q with the values from set V or 4 adjacent if Q is in the set of N4 of P. So here Q can be any value in green color and with remaining in yellow color are their neighborhood. So totally 8 neighborhood it has, 4 in the horizontal, 4 in the diagonal way. So totally N4 of P plus nd of P. It represents n8 of P. And adjacency is 8 adjacency, which means that 2 pixels P and Q with the values from set V or 8 adjacent if Q is in the set of n8 of P. So we are already seen about n8 of P. In this, suppose if this 1, 2 is lying in this block, which means that for example P, the pixel is in red color, Q can be any value in the green color. For example, for the M adjacency, two pixels P and Q with the values from set V or M adjacent, we must follow these two things. First condition, Q is in N4 of P or Q is in ND of P, and the set N4 of P intersection N4 of Q have no pixels whose value are from V. For example, here V is equal to 1 is given. So in this example, we can see two pixels P and Q with the values from set V or M adjacent if Q is in N4 of P. First thing, B and C. So we represent this B and C as the coordinate. The neighborhood is shown as 1. So B and C are M adjacent. Then comes B and E are M adjacent in this condition. Next condition, E and I are M adjacent. Same way, E and C are not M adjacent because it does not satisfy the rule of the set V or the Q is in N4 of P. Next, we will see about connectivity and paths. Two pixels are said to be connected if there exists a path between them. Let S represent a subset of pixels in an image. Two pixels P and Q are said to be connected in S if they have the path between them consisting entirely pixels in S. For any pixel P in S, the set of pixels that are connected to it in S are called connected component of S. Path means a path from pixel P with coordinate x, y with pixel P with coordinate s, t is a sequence of distinct sequence with coordinates. So we'll see about with the example. Consider the image segment shown in the figure. Compute the length of the shortest 4, shortest 8, shortest m paths between pixels P and Q. For example, the code segment block has the b is equal to 1, 2. Which means that the path can be exist possible only with the combination of pixel values which has 1 or 2. But in this code segment of path, they have given all the combinations of 1, 2, 3 and 4 between P and Q. So the shortest path, the 4 path represents from 2, we can create a path, we can move to Q, only there exists 1 or 2. So when we move on, from 2 to 1, 1 to 2, 2 to 2, 2 to 1. Then we cannot exist. There will not be any possibility with the 3 because 3 is not in the V is equal to 1, 2. So now the path does not exist for a shortest 4 path. For example, for a shortest 8 path, the path exists because we can move on diagonally. In the shortest 4 path, we cannot move on diagonally, but we can move towards any way, diagonally or horizontal way. We can move towards the next path, next pixel using this shortest 8 path. So the path exists. So this is the way we should find the closest path and the nearest path which has a same pixel value lie in the V. And region. Let R be a subset of pixels in an image. Here, all the green color pixel values show region I. All yellow color shows region J. So, these two remaining red color pixels are not belong to R1 or Ri or Rj. Two regions Ri and Rj are said to be adjacent if their union form a connected set. Regions that are not adjacent are said to be disjoint. We consider 4 and 8 adjacency when referring to regions. Or regions are adjacent only if 8 adjacency is used. So here, the same example, here border or contour which represents the boundary of a region or is the set of points that are adjacent to points in the is the complement of or. Red colored one is not a member of border because this border of 1 which shows in the green color or the boundary point. This red color point is not belong to the boundary. So the red colored one is not a member of border if 4 connectivity is used between region and a background. It is 8 connectivity is used. Then comes distance measure. Next, we will see about distance measures. Some of the basic distance measures are city blocks distance, Euclidean distance are there. Before that, we have to see about some of the properties, reflexivity, symmetry and transitivity. Euclidean distance measure is nothing but square root of the distance to point we consider. City block distance is the sum of the modulus of the two distance difference. So here the pixels having d4 distance from x comma y less than or equal to some value or form a diamond center at x comma y. Pixels with d4 distance less than or equal to 2 forms the following contour of constant distance. Next comes the chessboard distance. Here the maximum of the point difference will be considered. In this case, pixels having d8 distance from x comma y less than or equal to some value r form a square centered x comma y. Pixels with d8 distance less than or equal to forms the contour of the constant distance. Equivalent distance. Here it is the straight line distance between two any pixels. City block. It is the distance based on the four connected neighborhood whose edges touch 1 unit apart and pixels diagonally touching or 2 units apart. Chessboard distance is also the metric that measures the path between the pixels based upon 8 connected neighborhood. Pixels whose edges or corners touch or 1 unit apart. Now, we can see an example. An image segment is shown below. Let V be the set of gray level values used to define connectivity in the image. Compute D4, D8 and DM distances between the pixels P and Q for V is equal to 2, 3, V is equal to 2, 6. This is the image segment given. For the position P and Q, we have to find the D4, D8 and DM. Now, consider the 0, 0 position as P and 4, position as Q. As d4 and d8, the distance depends only on the coordinates of pixel and not on the gray level of pixels. Therefore, coordinates of p, x, y 0, 0 is 2 and coordinates of q of s, t that is 5, 5 is 6. Now, d4p, q is equal to modulus of x minus s plus modulus of y minus t equal to 0 minus 4 plus 0 minus 4 that is equal to 4 plus 4 8 units. Same way, d8 of p comma q maximum of x minus s comma y minus t, which is nothing but maximum of 0 minus 4 comma 0 minus 4 that is equal to 4 units. dm is the distance between the two pixels depend on the value of the pixels along with the path and also on the values of their neighbors. In this case, if v is equal to 2, 3, here gray level values of pixel q equal to 6, which doesn't belongs to v at all. So there is no path through the which p and q are connected. Therefore, dm distance for this case is cannot be computed. That path does not exist. Next case, v is equal to 2, 6. Here also there is no path which p and q are connected. Therefore, dm distance for this case cannot be connected. Here we start the value from p. 2, 6 exists, 6, 2 also exists, 2, 2 is existing, again 2, 6, again 6, 2. Then this from this 2 we cannot move on to this 6 through 5 or any other way. So this also the point cannot be exist. We cannot form the point. Now you can try the following example by yourself. An image segment is shown below. Let V be the set of gray level values used to define the connectivity in the image. Compute D4, D8 distance between the pixels P and Q for V is equal to 2, 3, V is equal to 2, 5. Thank you.